Hello there, Calc AB. So I've been getting a lot of questions over email and stuff from people asking, Boris, I'm having so much fun with U sub. Can I do it with definite integrals as well? And of course you can. And today we're going to talk about that technique and then kind of the one little kink in your plans it requires. So first off, let's just go ahead and walk through an example, and I'm going to talk you through what happens that's a little different. Because I think that the first step of this is pretty straightforward here. Let's just start this with the normal U sub, right? So u, of course, would be 2x squared plus 1 because that's what's being raised to the power. My du would be a 4x dx. So we'll need to go ahead and slide a 4 in there, slide a 1/4 in there. And then when we rewrite this, we write it as 1/4 integral 0 to 1 of, okay, so that's u squared, and the 4x times the dx. Remember, it's all just multiplied in whatever order. That just becomes my du. Now, right here, you should recognize, though, you're in a bit of a pickle because these bounds are in terms of x, but we want the bounds in terms of u. Okay, and we can change that actually very easy by plugging in to the formula for u. So we're going to plug the bounds into the formula for u. And this is like by far the fastest way to do these problems. So I just make a little table and we're going to use this equation. So my x bounds, the bounds were 0 and 1. And I'm going to plug them into this equation. So u is 2 times 0 plus 1, that's 1. U is 2 times 1 plus 1, that's 2 times 1 plus 1 is 3. Okay, so now I can rewrite it with the new bounds. And we always want to do this. We want to write this as 1/4 times integral 1 to 3 of u squared du. Now, here's the beauty about this strategy. By changing the bounds to also be in terms of u, the beauty is you don't actually have to plug back in for x. So if this is a definite, just plug in the new bounds. Plug in the new u bounds. You definitely don't need to and don't want to resubstitute back for x. Don't plug the x back in. So when we do this integral, this will become 1/4 times u cubed over 3 going from 1 to 3. That's a really bad u, I'm sorry. So this is 1/4 times u cubed over 3. So of course we could write that as 1/12 times u cubed going from 1 to 3. So that's 1/12 times 3 cubed minus 1 cubed. 3 cubed is 27 minus 1, which is 26 over 12. Notice the beauty of this. I never had to plug the x back in. I just got this nice easy integral that I could evaluate. So that's the key thing we need to do with u sub, is we need to go ahead and do the u sub and do the du and everything, but also we need to change the bounds. So we need to make sure that we write those bounds in terms of u when you do u sub. Okay, let's do one more example here. So for this first example, the second example, this one's going to have a little extra work. So I'm going to say find the average value of f of x equals e to the negative 2x from x equals 0 to x equals 2. Ooh. So this is an average value problem. We've seen those before. So this is like my A and this is my B. Because it's asking me to find an average value, we need the 1 over B minus A. So 1 over 2 minus 0 times integral 0 to 2 of e to the negative 2x dx. All right. So this is, of course, just 1/2 integral 0 to 2 of e to the negative 2x dx. Okay, so that's my setup for average value. And now let's go ahead. We're going to do a u sub on the part inside. So in this part, of course, we see a negative 2x in parentheses, so that would be a good choice for u. And then the derivative of that is a negative 2 dx. Okay, so we need a negative 2 here. We balance the positive 2 in front. Oh, that's cute. The 1/2 and the 2 are going to cancel. Nice. So this just becomes integral 0 to 2 of e to the u. Oh, I forgot to change the bounds. What a bad person I am. So I need to go ahead and change the bounds too. I like to do this right away, honestly, before I even start rewriting anything. So x went 0 to 2. So again, I just plug these in. So u is negative 2 times 0, that's 0. Negative 2 times 2 is negative 4. So this goes 0 to negative 4. So that's going to be e to the u going from 0 to negative 4. Remember the 1/2 cancel with the 2 that happened in the du. So this becomes e to the negative 4 minus e to the 0. I guess you write e to the negative 4 minus 1. That'd be fine too. Okay, so, oh god, I screwed up this too, Jesus. I forgot a -2, so this should have been a negative out there. So it should be a negative. Oh my goodness, what a train wreck this is becoming. Okay, so that's negative, that's a plus, so negative plus. Sorry about that. Okay, I apologize for my mistake on that problem. So that's what you want to do. Make sure you change the balance as well as the u and the du. Okay, so that was an average value problem where you had to do u sub. I'm going to give you guys a chance to practice right now. So what I'm going to do is I'm going to write 3 problems down. I want you to, after I write them down, I want you to pause the video and then solve each of these 3 kind of in your notes like you would in class. And then we'll talk about them afterwards in just a sec. So first off, I want you to do the integral 1 to 3 of 6 over 1 minus 3x dx. Second off, I want you to do the integral 1 to e of natural log of x over x. That one's a little tricky. Think carefully about the u. And then now I want to give you this problem. So I'm going to tell you that f is, capital F, is an antiderivative of little f of x. And I'm going to tell you that big F of 0 equals -2. Big F of 12 equals 8. And I'm going to ask you to find the integral 0 to 6 of f of 2x dx. Okay, now go ahead and pause the video. These problems should take you about 8 minutes to complete, and then we'll come back and go over. Okay, now hopefully you had a chance to do these problems. Maybe you got stuck on some parts. That's okay, but let's go through them quickly, the first 2 especially. So, okay, the first one here, integral 1 to 3 of 6 over 1 minus 3x. When you look at this, remember that typical, or not typical, but oftentimes we pick the u to just be the denominator, and this is no different. The derivative of that is a -3 dx. So I need to slap in a -3 here, and that'll be my du, and slap in a -1/3 in front. So this will be -1/3 integral, and then we have 6 times 1 over u du. I do need to change the bounds, of course. They go 1 to 3. So 1 minus 3 times 1 is -2. 1 minus 3 times that's -8. So this becomes -2 to -8. Okay, so let's move this 6 out in front. 6 times -1/3 becomes -2 integral -2 to -8 of 1 over u du. So, okay, what that's going to do when you integrate ln of u, you're going to get integrate 1 over u, you're going to get ln of u, going from -2 to -8. So what we'll end up doing is get -2 times ln of 8. Remember, the absolute value is going to make it positive, minus -2 times ln of -2. Okay. Okay, cool. So that's the strategy on that problem. Okay. So let's go from here. Number 2. Number 2, I asked you to do the integral from 1 to e of ln of x over x. You might have had trouble choosing the u for this problem. Now, you might try choosing u to be x, but then your du is dx, your goose is kind of cooked on that. The actual u you want to choose is natural log of x, because the derivative of that is 1 over x, and conveniently we have a 1 over x dx in here. Let's change the balance as well, and that's going to work out nicely. So when I take the natural log of 1, that's 0. The natural log of e is 1. So this problem works out really nicely. It becomes integral 0 to 1, the ln x is just u, the dx over x is my du. So this works out really cleanly to just be u squared over 2 going from 0 to 1, which is just 1/2. Okay, cool. So that's a tip. Remember, the derivative of ln is 1 over x. That'll help you on a problem like this. Okay, let's get to the third problem. The third problem tells you big F is the antiderivative. Big F of 0 is -2. Big F of 12 is equal to 8. And they ask you to find integral 0 to 6 of little f of, I think it was 2x, yeah. Little f of 2x. Now, here's the trick you want to use. If you're doing one of these problems, there's just an f in it. What you want to choose for your u is just whatever is inside the parentheses, right? We do that with sine or cosine. So pick u to equal 2x. Now let's trust in the light. So the derivative of that is a 2 dx. Okay, we need to put a 2 here. We need to put a 1/2 in front. Let's go ahead and change the balance too. By the way, they love asking questions like this on the real AP test. So when I go from here, x goes from 0 to 6. So I'll plug those into this formula. I always want to change the balance and write them in terms of u. So this is 2 times 0. This is 2 times 6. That goes 0 to 12. So this is just going to become a 1/2 integral 0 to 12 of f of u, and that's a du. Okay, so now we get to this question, right, of how do we integrate little f? Well, in the problem, they told us that big F is the antiderivative. Okay, it's 420, nice. All right, so this is going to become 1/2, well, for a couple of you, 1/2 times big F of u going from 0 to 12. So if big F's the antiderivative, you take the antiderivative of little f, you're going to get big F. So this is going to be 1/2 times big F of 12 minus big F of 0. Okay, and that's great because we have those values, right? Those were given to us right here in the problem. So now I'm going to take those antiderivative values and I'm going to plug them in. So when I plug them in, I'm going to get 1/2 of 8 minus a minus 2. So that's half of 10, which is 5. So the trick on this problem, I think, was choosing the u to be 2x. And just saying, okay, if I integrate little f, I'm going to get the antiderivative big F, and making sure I change the balance so I have the values that I do. Make sure that when you're doing these definite integrals, you're always changing the balance. Okay, so that's definite integrals. Thanks for watching. I'll see you guys in class.